Now I want to show you how to do a limiting reactant problem. Limiting reactant problem is just another type of stoichiometry problem. The difference here is instead of having one given and one required, in other words, one thing you're reacting with something else and you have excess of the other thing. In this case, if you notice, you have two givens. All right, so here you got 2.50 grams of sodium and 3.5 grams of chlorine gas. And then it says, how much product will I get? So first of all, with any stoichiometry problem, you're going to want to have a balanced chemical equation. And then as soon as you have the balanced equation, then you're going to have to solve it with two givens. So let's go and see how this works. All right, so next thing we're going to do, or first thing, is a balanced chemical equation. We have sodium plus chlorine reacts to give sodium chloride. And if you check, it's going to be a 2 there and a 2 there to balance the equation just right. All right, so next thing is we identify the givens and the required. So this is just like any other. It's just you have two givens. So we're going to call this given 1, and then over here we're going to call this given 2. And then required, or desired, we're just going to have to solve it twice. So now we're going to go into the stoichiometry part of it, and we'll start with the sodium. So 2.50 gram of Na. All right, and we'll just go on down the line and solve this and find out how much sodium chloride we get. So next thing we do, of course, is we go into moles. So for every 1 mole of sodium, it weighs 23 grams. Here's molar ratio. So molar ratio for every 2 mole of our given, that's sodium, we have 2 mole of NaCl. And then finally we get the mass on this thing. For every 1 mole of NaCl, it weighs 58.5 grams. So when we run that in the calculator, we end up with 6.36 grams of NaCl. All right, now what we do is we run the same calculation, only this time we do it with chlorine. And we notice our given's a little different. So we've got 3.50 gram of chlorine. Remember, chlorine's diatomic. You could also get, since chlorine's a gas, you could get that as a volume. Either way, next step, you go from whatever the quantity given is into moles. So 1 mole of this stuff, Cl2, weighs 70.9 gram. And then our molar ratio for every, in this case, 1 mole of chlorine, you get 2 mole of NaCl. And the last part of the calculation is identical. 1 mole of sodium chloride weighs 58.5 grams. So with this one, basically, you would get 5.77 grams. So out of this, we get a couple of, shall we say, observations. First of all, the limiting reactant is the one that gives you the smallest amount of stuff. So you would have to say that chlorine is limiting. All right, so that's the limiting reactant. You can't make any more than what you have. All right, and then the other thing you would say, oh, by the way, based on that limiting reactant, you would call this 5.77 grams the theoretical yield. Now, that simply means that if all things went perfectly and you didn't wash any out or whatever, that would be the amount that you would expect to get. So we call that thing the theoretical yield. And the last thing we would say is that sodium, since you could have made more, you notice over here with your 6.36 grams, we call that one the excess reactant. And I'm going to use excess, it's EXCSS, but excess is kind of just another way to show it. So anyway, at this point, we've kind of identified a lot of the stuff. How much product will I get or do I expect to get? That's the 5.77 grams. Which reactant is limiting? Well, we identified that chlorine is limiting, and how much excess reactant remains. Now, we still have to do that. and I'm going to show you exactly how to go about it. What we're going to do, just to tell you the process, we're going to take the amount that we got, that'd be a theoretical stuff, and the 6.36 grams, that's the stuff we thought we would produce. So, or could have produced if we had more chlorine. So I'm going to take those onto the next screen, and I'm going to subtract them, and then when I subtract them, that's going to give me a number of how much chlorine I could have made. So now what you would have, I mean, all right, I rewrote it for you. With sodium, you could have made 6.36 grams, but you didn't have enough chlorine. Chlorine is limiting, so the theoretical amount you made was 5.77 grams. So really, when you kind of get around, how do you figure out how much excess? If you could just subtract these two, then what that's going to tell you, and subtracting is like 0.59 grams of NaCl. That's the amount of excess you would have made, or the amount you could have made additionally, had you had enough chlorine to pull it off. Now, what you do is you take that number, 0.59 gram of NaCl, and then you just go back and you solve for the excess stuff, and that'll tell you how much excess was actually left over. So let me just show you the process. You're back to stoichiometry, 1 mole of this stuff. Sodium chloride weighs 58.5 grams, and then for every, and I'll go back to my equation, for every 2 mole of sodium chloride, I needed 2 mole of sodium, and then for every 1 mole of sodium, it weighs 23 grams. 23 grams. So I run that on my calculator. I want to get this one right, and I get that it's 0.232 grams of sodium. So I went back and solved, and what that says, what the sodium really represents, is how much, so it's how much is left over. So that is the excess sodium that's still left over after you finish the process. So that's how you do one of these limited reactant problems. There was one more thing back in the original equation. It said if I actually got, so let's see, this is one more dimension of this. It says I actually obtained, which means I got it off the filter paper or however, I got 4.50 grams of product. So to calculate this thing called a percent yield, what I do is I take the actual amount over the theoretical amount. Remember, theoretical is how much I calculated I would have gotten, and then that's times 100. So I look at my values, it says I actually got 4.50. Now, guys, you get that straight out of the problem, okay? The problem tells you that. So we're going to do 4.50, and then the theoretical yield we're going to pull from up here. There's your theoretical amount, and we're going to put it down below here, 5.77 grams, and that's times 100. So my percent yield in this case, after I finish my reaction, is going to be like 78.0%. So that's one other type of thing. Again, a lot of students get confused. Where did this actual yield thing come from? And it's given in the problem. So if you go back to the original text on page 1, you'll see where that came from. So we have a few answers here. It's got 4 or 5, a lot of dimensions around it. But realistically, it's simply a stoichiometry problem that runs a couple of times with some comparisons. So have a look, and we'll be discussing it in class additionally. So when we get back to this chapter, we're talking about, let's see, we have the types of things we have. We have regular old, shall we say, garden variety stoichiometry problems. Those are going to be mass to mole, mass to volume, all that kind of stuff. Then we're going to have these limited reactant problems. And remember now, with limited reactant, you had a couple of things you had to do. You had to identify a theoretical yield. You had to, after you got the theoretical yield, you had to figure out which one was the limiting reactant. Okay, so limited reactant. You had to figure out which one of these was the excess reactant. And then you ran that back through the calculation and you figured out how much stuff left over. So how much stuff left over. And another way to say that is, how much excess stuff did you have? And then finally, there's this thing out there called a percent yield. Pretty much, remember, the percent yield, the problem's going to tell you how much you actually obtained. You take that over the theoretical amount times 100, and you're home free. So I would say we've probably done a pretty thorough job today on this, so hopefully this will help you in your endeavors to get a high grade on the test. Enjoy.